Okay, so once you feel like you have gotten to grips with the general solutions of a differential equation, the next step is to look at what we mean for a particular solution. So if you remember from the first video, we talked about the fact that a general solution is where you've got that constant of integration, and if you were to draw or graph the potential answers, you would actually have a family of curves. You wouldn't be able to pinpoint exactly which one it is. Now, a particular solution comes into play when we are given a value for x and y, which we have called boundary conditions. And essentially, the difference between the general and the particular solution is that we want to sub in those boundary conditions in order to find a particular solution. So in other words, to pinpoint exactly which curve the answer is. So what I have done along the right-hand side is I have changed the steps to add in the fact that after we've done separate, so step 1 and step 2 integrate, what we're actually going to do is we're going to sub in the boundary conditions before we do our manipulation. Okay, so as we said, step 1 is to separate. So I'm going to take this differential equation and I'm going to put the x's on one side and the y's on the other. Now at the moment you may be able to see the fact that the x's and the y's are kind of together in the exponential. So what I'm actually going to do is I'm going to change that to dy by dx equals. Now in indice rules we know we get a subtraction when those two things are divided. So I can make that e to the 3x over e to the y. Essentially I'm kind of like unsimplifying my answer. Okay, that then makes it a little bit more obvious how to separate. So I'm going to take the denominator up onto the left. So we have e to the y dy, and then on the right we've got our e to the 3x dx, and again we know that we need to put our integration symbols. So that's our step 1 done, happy days. Step 2 is that integrate. Okay, nice and straightforward. So if I were to integrate e to the y, we know that e just integrates to itself, so that's going to give me, I'm going to write it here, e to the y, and then e to the 3x becomes a third e to the 3x, and then we need to add our constant on. In video 2 we'll have seen that it's usual format that if your expressions are all in terms of logs, to put your constant in terms of logs, and if you're all in terms of e, then it does make sense, I think, to put e to the c. You don't have to do it that way, you can just put plus c, but I think that makes a little bit more sense. Okay, now I think then it's actually quite sensible to sub in the boundary conditions now before I start trying to rearrange this expression and make it y equals. Now that's a personal choice. You can do the rearranging first and then sub in the values, but I just think it's easier to move things around that are numbers rather than algebraic expressions. So what I'm going to do now, and I've kind of called this step 3a, which is the box down in yellow down here, okay, I'm going to rename that because I do love a rhyme. We've got integrate, we've got separate, we've got integrate. I'm going to call this step evaluate, okay. So evaluate means I'm going to sub into the expression above the boundary conditions. So I've got e to the ln 7 over 3 equals a third e, 3 times 0 is going to give me 0, plus e to the c. The e and the ln cancel out, so that's going to give me 7 over 3. E to the 0 is just 1, so that's a third, plus e to the c. And if I work that out, that's going to tell me that e to the c is therefore 6 over 3, or 2. So I can now go back to my comes down again. No, okay, I'm going to go back to this expression and I'm going to sub in there that e to the c is 2. So my answer, my solution at the moment looks like this. E to the y equals a third e to the 3x plus 2. And we are almost there. Ideally, we would want to make this y equals rather than e to the y equals. Again, it doesn't ask me to in the question, but it's good practice to do it if you can. And so this is the step that we were calling manipulate. In other words, rearranging. Okay, so I'm going to make that y equals by simply taking the natural logarithm of everything on the right hand side. So a third e to the 3x plus the 2 all in one go, not separate logs, all in one go. And that is my final answer. So let's see if I can get onto the next slide.